Hi, my name's Steve Mann and welcome to Paper Classroom. Here we have another science tutorial, and in this science tutorial we're going to talk about the evolution of atomic theory. Before we get started, it's worth talking about atoms and elements for a moment. The word atom comes from the Greek word atomos, which means indivisible. And that's because around about 400 or so years BC, the Greeks had this idea that if you took any material and you chopped it down into smaller and smaller particles, you would eventually come to a really tiny particle that was impossible to see, but it was so hard it would be impossible to break down into any smaller particles. And all substances were built up of their own version of this very tiny small particle, and those particles were called atoms. Sometime later, that idea was revised because people learned about or learned to understand the difference between mixtures, compounds, and what today we call an element. So a mixture is two different substances that are just physically mixed together and can easily be separated. Something like sand and sugar, for example, or sand and salt. A compound is where two or more elements have undergone a chemical reaction to form a whole new substance. But if you do take that substance, you can pull it apart and you can decompose it and make it go back to its original constituents. And that leaves us with an element. An element is something that cannot be broken down into anything simpler. So the periodic table is talking about elements. We're now talking about the atoms, we're talking about elements. So we need to really understand what an element is. So I hope that's clear now. Now, following this Greek idea from nearly 2,000 years ago, that an atom was this indestructible tiny particle, things moved on, and by the 1850s, they'd realised that although atoms were electrically neutral, they did have positive aspects and negative aspects to them. And in the 1850s, J.J. Thomson came up with the very first idea of what an atom might be like. And a common picture is a Christmas pudding, and it was known as the Plum pudding theory. It's also known as the currant bun theory or the raisin bun theory, as you can see here. So Thomson's idea was that an atom was this spongy mass of positivity, and dotted in it were little negative electrons, and there were just enough electrons to cancel out the positivity of the sponge, leaving a neutral atom. That idea persisted for more than 50 years until eventually Rutherford did his famous gold foil experiment, where he fired electrons at a film of gold, expecting it to pass through, but a certain proportion of the electrons came straight back at him. And that made him propose this theory that an atom wasn't a spongy mass of positivity with little dotted negative particles around it, but there was a core, there was a centre to an atom, a very dense centre full of positive bits, and the electrons were whizzing around the outside, just randomly whizzing around the outside in any old random fashion. And the number of electrons, again, balanced the positivity of that central core. Now, a while later, Niels Bohr made a slight modification to this theory. He said, I agree that the the middle bit of the atom, the nucleus of the atom, has all these positive bits. And I also agree that the electrons whiz around on the outside, but I don't think they live randomly on the outside. I think they're in very special orbits or very special shells, so very discrete, so they're very predictable. You always know which shell they're going to be in. And these shells will represent things like energy levels. He also thought that within each of those shells there would be subshells, so the atoms could move up and down these subshells, whether they're gaining energy or losing energy. And he also proposed, he said, I don't like the idea of all these positive things in the middle of the atom in the nucleus, because if you take some magnets, if you take two positives of a magnet, put them together, they'll repel each other. Take two negative ends of a magnet, try and push them together, they'll repel each other. So why don't all these positive bits in the atom repel each other? So his idea was there must be something else, there must be another particle in the middle of that nucleus that stops these things repelling each other. And he called it a neutron, but it was only a proposal. Now, he also said, as I mentioned a moment or two ago, that each of those orbitals had suborbitals. Now we're here. This is some really deep chemistry, really deep physics. It's beyond what we need to know as paper makers. So I'm just going to tell you that this thing exists. So if you want to investigate, you can do. But it's not in this level 2 course. It's not really relevant for paper makers, but it's just nice to know. At this stage, people were talking about not just the position of an electron, but they were getting onto more statistical things. What was the chances of an electron being in a certain position? And so when you're talking about what the chances are, as you can see here, you've got all these shapes. It's going to be somewhere in here, but you don't know where. So they're talking about suborbitals having particular shapes. That's beyond this course. I'm letting you know it's there, but we don't really need it. In 1932, Chadwick, an English chemist, actually proved the existence of neutrons, and for which he got the Nobel Prize. Following on from him, there were people like Einstein and Schrödinger, and they made life even more complicated. They showed us that what we thought were simple fundamental particles, protons, neutrons, and electrons, weren't really those simple objects. They weren't sort of billiard ball type things as we all imagine, and that there were other particles making up those particles. So this is the modern theory of the atom. I do know it exists, I'm letting you know it exists, but for what we need in paper making, this is far beyond our needs. So that's all I'm going to talk about the evolution of atomic theory. I hope you enjoyed it. I hope you find it entertaining. Please enjoy our other videos, and I look forward to seeing you in the future.